Okay, so on our graphing calculators, what we want to do is go ahead and go into y equals. So we're going to go into y equals. If you have anything in y equals, go ahead and clear out what is currently in your y equals. And then what we're going to do is we are going to enter in some of the data from here. So in y1, you're going to put x plus 5, and in y2, so we're going to type in x plus 5, and then in y2, you're going to enter negative 2x plus 5. And then what I want you to do is to graph those. And if your graph is kind of funny or you don't see anything, always hit zoom 6. And what that does is take you back to a graph that is negative 10 to 10 and negative 10 to 10 all the way around. So when I look at this graph, I'm taking into account that they cross each other one time. I'm taking into account this has a positive slope, this has a negative slope. So then what we're going to do is go back over here and answer all of the questions, but for only part A. So it says, do the graphs have any points in common? If so, how many? So I would say that yes, they do. And we saw that they only crossed each other once, so they have one point in common. It says compare the slopes of the graph. What is the relationship between the slopes and the number of points in common? So the slopes are opposite and not really related. Okay. So now let's go back up, and this time we're going to graph equations B. So you're going to go back to y equals. You're going to type in 3x plus 2, and you're going to type in 3x minus 1. And then you're going to graph them again. Now this time when we look at our graphs, what we should notice is that this line and this line never touch each other. So if we go back to our question, it asks us how many points do they have in common? And in this case, the number of points they have in common is 0. So do they have any points in common? The answer is no. And then what is the relationship between the slopes and the number of points? Well, in this case, the relationship between the slope and the number of points is the slope is the same. Okay. Going back and graphing one last time, you're going to go to y equals. You're going to type in negative 4x minus 2. And then you're going to type in parentheses 8x plus 4, close parentheses, divided by negative 2. So your y equals should look like that. This time we're going to hit graph. And I notice that I only see one graph on the page. Well, the reason that there is only one graph on the page is because these equations are identical. So what that means is that how many points do they have in common? All of them. Compare the slopes of the graphs, what the relationship is between the slopes and the number of points they have in common. Well, if you simplify the second equation, we see that that is equal to negative 4x minus 2. So what we'll notice is that what is the relationship between the slopes? Well, the slopes are the same, and they have every point in common. So that ultimately leads us to the table down below. So it says describe the 3 types of lines, how many points they have in common, and if their slopes are equal or different. So what we're going to do is talk about exactly what we just saw. So example letter A was an example of intersecting lines. Example B was an example of parallel, and example C was an example of coinciding. So in example A, how many points of intersection? They had 1. In example B, how many points of intersection? None. And in example C, how many points of intersection? Infinitely many. So this unit, we're investigating 3 different types of lines. We're investigating intersecting, parallel, and coinciding. Intersecting lines will never have the same slope. Parallel lines will also always have the same slope. Coinciding lines will also always have the same slope. And intersecting lines can have the same y-intercept, but they don't have to. Parallel lines cannot have the same y-intercept, because if they had the same y-intercept, that would make them coinciding. So on the other side, coinciding lines must have the same y-intercept. So again, this chart is a very useful chart. It has all of the key ideas that go in with parallel, intersecting, and coinciding lines. Okay, so we are going to look at some new vocabulary today. So we have a couple different vocab words. We have a system of equations. A system of equations is a set of 2 or more equations that use the same variables. A system of equations is a set of 2 or more equations that use the same variables. A linear system is a system of equations that only has lines for their graphs. So we're going to start with linear systems, but then we're also going to advance into mixed systems. The solution of a system of equations is the intersection of the graphs. The solution of a system of equations is the intersection of their graphs. And an independent system, or a system of linear equations that has one solution. So an independent is a system that has one solution. An independent system is an intersecting set of lines. An independent system is an intersecting set of lines. A dependent system is a system of linear equations that has many solutions. And an inconsistent system is a system of linear equations that has no solutions. So graphically, like I said, we have 3 different types of systems, and each one has their own set of terms that go with them. So intersecting lines have one solution, and they are considered an independent system. Coinciding lines have no unique solution. They are a dependent system. And then parallel lines have no solution, and they are considered inconsistent. Parallel lines have no solution, inconsistent. So it says classify each system without graphing. In order to classify these systems without graphing, we need to put all of our equations into y equals mx plus b form so that we can compare their slopes and really talk about, what is happening among those graphs. So what we're going to do now is equation 1. The first part is in y equals mx plus b form. My slope is 3. My y-intercept is 2. So what I'm going to do is rearrange the terms in the second equation to also be in y equals mx plus b form. So I'm going to add over the 6y, or rather 6x. And then I need to divide both sides by 2. And I get y equals 3x plus 2. So the slopes are the same. The y-intercepts are the same. So these are coinciding lines. And that is our classification. So you want to know if they are coinciding. And then our other classifications go with infinitely many solutions, and then the last classification comes from, are they independent, dependent, or inconsistent? So again, if you go back to our lovely chart on the previous slide, we can see that coinciding lines are dependent, because if you go back to our vocabulary, dependent systems have many solutions. So everything should sort of make sense in terms of that. So then coinciding, many solutions. And then the last part is that they are a dependent system. Example 2, we need to rearrange both equations this time. So in the first equation, we are going to subtract 3x. And then in the second equation, we need to subtract 15x. And then divide by 5. what we'll notice is that these lines have the same slope, which means they are parallel, but parallel lines are inconsistent and have no solution. In example number 3, the first equation is already solved for me. The second equation says we're going to add over the 4x. Then we're going to divide by 2. And this time when I compare their slopes, the slopes are different. The y-intercepts are the same. But different slopes tell me they are intersecting. One solution. And I like to think intersection goes with independent. So the intersecting independent have one solution. And then example number 4, we have to add over our y. Divide by -1. And then in example 4, part 2, we just have to subtract 3x. Or just 3 rather. So once again, I can see I have y equals x minus 5 and y equals 2x minus 3. So my equations are independent, intersecting, and one solution. So again, it's all referring back to that same table we did at the very beginning, talking about slopes, y-intercepts, and then that leads to their terminology and graph importance. Okay, so your homework is that very next page in your packet. So you're simply going to do that very next worksheet in your packet. And have a wonderful weekend. When you are done with that homework assignment, there is a Dropbox already out on Moodle. So again, like I said, Fusion Flex was, again, now on your Fusion Flex, we are done with chapter 2. I'm going to give it like a day or two more in case I need to do some stuff on there. But we are starting chapter 3. So you should have a chapter 3. It has a folder with your notes in it. The notes are also on Teams. And then there's a Dropbox for tonight's homework assignment. And then there's a Dropbox for next Wednesday where you'll drop off Monday and Tuesday's notes. All right, guys, have a wonderful weekend.